Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Whispering Internal Loop Skyscrapers by Yitrio. And here are the rules. Normal Sudoku rules apply, which means fill the entire grid with the digits 1 through 9 such that there are no repeats in any row, column, or 3x3 region. We also have to draw a one cell wide loop of orthogonally connected cells. The loop may not touch itself, not even diagonally. So a valid loop could be something along the lines of, say, like this, right? What it could not do is it could not do something like this, which it would touch itself orthogonally. Nor could it do something like, say, how do we want to go? Okay, let's just do this to here, to here, to here, to here. It could not do something like this because this would be touching itself diagonally. The loop acts as a German whisper line. So on this loop, you have to have adjacent digits on the loop must have a difference of at least 5. So for example, if this were a 3, this would have to be an 8 and a 9 in some order next to it, because 8 and 9 are the only digits that are 5 or more away from a from a 3 on a German whisper line. We also have internal loop skyscrapers, which is why this puzzle is called Whispering Internal Loop Skyscrapers, where each cell on the loop represents a skyscraper with a height equal to its value. Non-loop cells are not skyscrapers. Okay, that's interesting. A digit in a clued cell gives the number of skyscrapers visible in the indicated direction, not including the cell itself. Where skyscrapers block the view of skyscrapers with the same or lower height behind them. The clued cell may or may not be on the loop. So that's these arrows, right? So for example, this, if it's say this was like a 3 and an 8, this would then see two digits on the two skyscrapers. Because remember, non-loop cells are not skyscrapers. So this would then have to be 2. But then this would have some problems because this would then be, this would fail other issues. This would see one skyscraper, so this would be 1, right? These would be 0 because they see no skyscrapers here, which gives you a hint. This could be something like 3, 8, 2, 7, 1. And this would see 1, 2, 3 skyscrapers because it would not see 2 or 3 because they would be blocked by the 7 or 8. So this would have to be 3 if that were the case. Remember, non-loop cells are not skyscrapers. So you can't see those if they aren't a skyscraper itself. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, this sees well, this sees 2 cells at most, right? Because, so it would see 1 or 2 skyscrapers here. But this sees at least 2 or 3. So these are both low. This then must see this cell and whatever this skyscraper sees. So this must be on the loop. So this is on the loop. This is on the loop. This must be what? 7 through 9 because it cannot be 6 because it sees. Therefore, this would see 1 skyscraper, and this would see 2, right? Because it will see any of these. This cannot be on the loop, though. So therefore, this must be on the loop. This cannot touch this, because this cannot go here because it would touch this cell. So this is not on the loop, which means these are on the loop. This has to go this way. This cannot touch, so this is not on the loop. If it goes that way, it would touch. This has to be 3 because it sees 2 unique digits. It can't be 1 or 2. So this is 3, which forces this to be 8 and 9 pair. That's 3 in the corner. We celebrate because, I don't know, this is 6 or 7. This has to be a 2 because it cannot be 1 or 3, and it sees 2 unique digits on a German whisper line. So this is 2, which makes this 7, 8, or 9. If this were to go here, this would have to be a 4, but that's not allowed because 4 can only be next to 9 on a German whisper line, so it has to go this way. So this is not on the loop because otherwise it would touch itself. So this is must be next to 6 or 7, therefore this is a 1. This cannot see any digit here. It must see, this must be 2 or 3. We're not sure which. So it must see one of these being a skyscraper. Well, whichever one it does see. This would be even. This would be low. This would be high because on a German whisper line, especially on a loop, you know if it's on the loop, it has to be a certain set, right? Because you'll alternate between low and high digits on a German whisper line. So if this is high, this would be low, this would be high, which would force this to be a low. If this were a high and it only saw that, that would not work, I don't think. Because this could, to see more than 1, you would have to have this be 6 and this to be 7. But this 6 would require a 1 to be here and a 1 to be here, or a 1 to be here and a 1 to be here. And these are both 1s, right? So this cannot be the only new skyscraper it sees. It has to see this skyscraper, definitely. And this is a low. So this would be 2, 3, or 4 here. I think this has to be 2 then, because it will only see either these 2 or it'll see this digit and that digit, but that's it. So this has to be a 2, which forces this to be 3 or 4. It cannot go this way on the loop because there's no difference of 5 here. Therefore, this is not on the loop. Let's make these gray. So we want to be able to distinguish between highs and lows. So this is low, this is low. This has to be low. So lows can only be where? Here. Here. Here, right? So like a checkered board pattern, this tells us some decent information, right? So this can, if it's on the loop, it has to be a low in these cells. If these are on the loop, they have to be a high. Okay. We do know... This is interesting. This must be at least 3. Can it be 4? Maybe. If it sees low, low, high, well, I think it can only be 3 or 4 here, right? If it sees low, 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 and high, that's 4. But if it sees low, low, then high here, it can only see another high here. If it sees low, high, it would see high, high here. So this is 3 or 4 also, and therefore cannot be part of the loop. Because it would have to be high if it's part of the loop. This has to be see 3 skyscrapers. It could see high, high, high. That's possible. This sees that one. Same here, I think. This could see 1. It could see 2. It could see 3. Right? Or 4. It could be 1, 2, 3, and that one. Right? If it goes something weird like this. So this one we know, oops, edge. Let's make it red. So this is part of the loop right now. This is part of the loop. This it could see 4 or 5. Actually, can't even see 5. It could see 1, 2, 3, 4. That's possible. Or 1, 2, 3, 4. Can it see 5? It sees blue, 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 red. Once you see a red, you can't see any more blues. So you could see blue, red, red, red. That's 4. Blue, 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 red, red. That's 4. Red, 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 red. That's 4. Blue, 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 red. That's 4. So this is always 4. So this has to be 4. Could still be part of the loop. Actually, no, it cannot. If it's part of the loop, then this would be part of the loop, and it would have to see 4 skyscrapers, which would mean 6, 7, 8, and 9, which is not allowed. So this is not part of the loop. It must see 4 skyscrapers. So it's either the 4 reds, the blue with 3 reds, 2 blues with 2 reds, or 3 blues with 1 red, or 4 blues. 4 blues is unlikely. Actually, you just can't. You have to get to a red. That's interesting. So I think it has to be 1 blue with 3 reds here, right? To be able to see. If cannot be red here, because that would force this to be 4 reds that you see, and that would be 6, 7, 8, and 9. This would be 6 without a 1 possible to be here, because this can't be 1 because of that 1. So this cannot be part of the loop. It has to go here and seize that. So to get into it, it has to go here, then here. And it must see 3. So it could go something like this. Well, no, it has to go in here, which means it has to go here. So then it must see 3 reds here. So we know this is a border. It goes to at least here. It could go further, but we're not sure. So since it goes in here, this must be a cell that it goes into. This cannot be. These cannot be because it just goes straight down. So this has to be right because it must enter here and it must see these 4 at least. So it must see this, 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 and this. So this is, it sees this. It could be 1 or 3. Cannot be 2 or 4. It must see this. It must see this one. It must see that one. So this is less than this. This could be 9. This would then be 8 at most. This is 7 at most. But if it sees this, so since this is 7, 3 can at most. Well, this sees 2 unique digits on a German whisper line, so it has to be 7. So this has to be 7, 8, and 9. That leaves this as 1, this is 2, and this has to be 3 to be in between. Therefore, this is 5 and 6 remaining. This is 5 or 6 remaining. How many cells does this? It sees at least here. So it could be, it sees 1. It could be 1 here that it sees. It could be 2 here that it sees. 1, 2. It can never be 4 because none of these are skyscrapers. So it would see this, this, and that at best. And cannot be 3. So it sees specifically either this and this, or, and this, it would see either this, or it would see both this and this, right? Well, this cannot be a high digit, so it cannot be on the loop. So since this is not on the loop, this cannot be part of the loop because the loop would have to continue here. So this has to be part of the loop. This is not part of the loop. So this is a boundary. This is a boundary. This is a boundary here. This boundary goes here. This has to be 1 or 2 because it cannot be 4. It's next to 2 unique digits on a German whisper line. So since it sees that, it will also see that. So this has to be 2 then. This sees 2 skyscrapers. This is a 1. So this could be... This is next to 2 unique digits on a German whisper loop. So this is 7 or 8. This sees 2 unique digits on a German whisper loop, so this can't be 6. This has to be 7, 8, or 9 here. These digits are 5 through 9, so this can never be on a German whisper loop. And this can't be on a German whisper loop. Since neither of those can be on the German whisper loop, you can't go down here and then connect to here. So these cannot be also on the German whisper loop. So it could go this way. Or just go straight through, or something like that. This can't be 7 because of the 7 here. Again, this can only see 3 at most. So this is 1 or 3 here that it sees. Therefore, this is not on the loop. It has to go to one of these, and then here, and then one of these. This must go this way. We don't know where next. Okay, so if it goes down to one of these, they would have to be a 4. But, because that's the only low digit remaining in box 7. But 7 or 8 can never be next to 4 on a German whisper loop, so it cannot connect to either of these. So this is not on the loop, and this is not on the loop. Because of this, it can never go back in here, so these two are not on the loop. It must go to here. So this is a border. It must go to here. This is 2, 3. It cannot be 4. This is 8 or 9. This is 8 or 9. So if it tried to go here, I guess it could do something weird like that, but then it would touch that, so that's not allowed. It could go to here, 1, 7, but then that doesn't work going that way. If this goes 1, 7, that doesn't work either. I don't think this can ever be part of the loop. So it can't go this way because it must connect to this cell. If it goes this way. If it tries going this way down, then this would be 1, because it cannot be 4, because it would be next to 2 unique digits on a German whisper loop. And this would then be 7, but then it cannot go here, because the 7 can only be next to 1 or 2, and it can't go here, because that would be next to 1 or 2. So this can never be part of the loop. Because of that, well, no, you can't go here either. This has to connect out to here. So it cannot go here because it would have to connect. You can't connect to here. And this can't go here because it would touch that. Therefore, this is not part of the loop. Technically, it could go something like this. That is possible. Unlikely, but possible. Remaining digits in box 7 are 4 through 8. Interesting. Okay, so if it entered this way and then did something like this, the problem is this would have to be a low and it's next to 2 unique digits. So this would be 3 next to 8 and 9. Therefore, this would have to be 7 at most. And you would have to connect this way, right? So it'd have to go out this way. So this would be next to a 1 and a 2, but we already have a 2 here. So this cannot go this way. So this is all ruled out. If we went 1 here, it could go... This would be 8 or 9 here. It could go this way. That's possible too. Could go this way, this way, so this way, this way, this way. It could even go this way, actually. Uh, what else could it be? Remaining digits in column 7 are 5 through 9. Because we have a 3-4 pair in 1 and 2 already taken. So this can't be 7 here. If this is 4, this would have to be next to a 9 and a 9. So let's say this was 4. If this was 4, this would be 9, 9. It would have to go this way, essentially. This would be 3, so this would be 2. Which would force this to be... this could be 7 or 8 still. This is still fine. That would be 8. This would be 9. This would be 8. This would have to be 1, 2, or 3, but it could be 1 or 3. That works. So that does work. Okay, if this is 4, though, this would be 3. This would have to see... I guess it could go something like this. That's possible. So it could be 2, 3, 8, 1, 9 that it sees. But this can't be 2. So, okay, this is 4. It necessarily needs... It cannot see these, just these. It has to see this or this. If it sees that, it still sees 3. If it sees this and these 4, this would have to... I guess it could be 3, right? 3... It could be 3... Can this ever be 4 is the question. It would see that one, so that's 3. It could go around, but then this would be 2, so it would not see that. It would see the 3, it would see the 7 or 8, and it would see the 9, which is not allowed. So what if about this? If this is 3, this would have to be 8 to be next to it on a German whisper loop. This would be 2, it would not see this. This would be 7, it would not see that, so it would only see 3. So this can never be 4. This actually has to always be 3, which forces this to be 4. That means this is 2. So this has to be 4. It's next to a 9 on a German whisper line, but it has to be a loop. So it has to connect here and here then. So this is a 9, this is a 9, this is 8, this is 9. So this is guaranteed. So it goes this way. Therefore, that's on the loop. These cannot be. This is 1 or 3 here. This cannot be on the loop. Plus, can it actually ever go in? No. So if it tries going in, it would touch itself here. So this cannot be on the loop either. So this only sees one skyscraper. It sees 9. So this would be 1, this would be 3. This can no longer be 9. This can't be 9. So it goes to here. This is a boundary. Boundary. So it cannot touch here. So that doesn't go there. It has to extend to here. So it goes this way. It goes to here. This is 7, 8, or 9 here. If this were part of the loop, it would have to be a 4 because 1, 2, and 3 are already taken. But 4 would be next to 2 unique digits on the German whisper loop, and that's not possible, so this cannot be on the loop. It could go down here and then connect to here. We're not sure which. Or it could just exit out this way. So this can't be on the loop because it can't exit out anymore. If we tried to go down, it would touch itself here. So these are no longer possible on the loop. So it could go here to here, or here to here, or some way here, right? If it went down here, this would be 3, and it could not be 8 or 9 here. I guess it'd go down here. That could be 8. So it could be 3, 8. That's possible. Okay. Remaining digits in row 4 are what? 2, 4, 5, and 6. This can't be 2. This can't be 2. This can't be 2. Where is a 2? It has to be here. That's fine. I could see that. I could just see these also. This sees 1. That's 3. This could be 3 and 8. It could go down that way. It cannot go here, but it could potentially go that way. Remaining digits in box 6 are 1, 5, 6, and 7. This can't be 8. This has to be 4, 5, 6, and 7 here. This cannot be 9 here. If we tried going this way. So, okay, say we tried going here. It would have to necessarily continue here. So this would have, one of these would have to be 3 and one of them would be 4. This would have to be 4 then, because we have a 4 here. But 4 can never be next to 7 or 8 on the German whisper loop. So it cannot go down. Therefore, it must continue this way. So it goes here, it goes here. This is 3, which forces this to be 8. Because 3 can only be next to 8 on a German whisper loop. Or 9, and this can't be here. So it cannot go this way then, because this can't be 8 or 9. So it must go down, which means this goes this way. This cannot be part of the German whisper loop then. It has to go this way. So it has to go here. It has to go here. This is a 9. This has to be 3 because it can't be 1, 2, or 4. So this is 3, which makes this an 8. Okay. So 9 cannot be here. The rest of these digits are 4, 5, 6, and 7. 4 has to be one of these two digits, so therefore this cannot be 4 because 4 can't be here. 4 can't be anywhere else on the loop. So it has to be here. Where is the 4 here? It has to be here. Remaining digits in column 9 are 1, 4, 5, 6, 7. But this can't be 1. 9 cannot be... Okay, so 9 is here and here. One of these is 2. The other one is... This can't be 2 because of the 2 in the column. So this must be a 2 here. This is 5, 6, or 7 because that's the only digits remaining. This sees two cells, two skyscrapers, 4 and 9. This sees 1, 8. This sees 2, 1 and 8. This sees 4, 1, 7, 8, 9. This sees 2, 1 and 8. This sees 1, just the 9. This sees 3, we don't know what this is. Okay. We have 8 2s. We know where the last 2 has to be. It has to be here. So this is 2. Where is the 9 then in box 9? Can't be here, can't be here, can't be here, so it must be here. So this is 9. Where is the 9 in box 8? Can't be here, can't be here because of the 9s in the rows. Can't be here, can't be here, it must be here. So this is 9. It's not a low, so it cannot be part of the loop. So this is not part of the loop, which means this can never be part of the loop. So it must go straight here. So this cannot be part of the loop either. It must go to here. So this has to go here. This has to go to here. This is part of the loop, so this could be 7 or 8. This cannot be 4 because it's not next to a 9, so this has to be a 1. It must connect to a 3, right? One of these is a 3. We're not sure which. If this were, okay, if it tried going this way, this would be 3, but then this would have to be 7, which is not allowed. So it cannot go down. So this is not on the loop. It has to go this way, which means this is a 3. Cannot go down because that would be not 8 or 9. So it has to go this way, which makes this an 8. So it connects to here. This is the loop here. This 8 eliminates 8 here, so this is 7. Remaining digits here are 3 and 9, but this can't be 3 because of that 3, so this is 9, this is 3. 4 cannot be any of these digits. These can't be 1 either. So where is the 4 in box 4? Can't be here, it must be here. So this is 4. This can't be 4, this can't be 4. Neither that can't be 4. So we have, this cannot be 7. Where is the 4 in column 4? It has to be here. So this is 4, which means this can't be 4. Where's the 4 in box 7? It has to be here. So this is 4. This cannot be 7. This cannot be 7. This can't be 4 or 7. This can't be 1. Where's the 1 in row 7? It has to be here. So this is 1. This can't be 4 or 1. Where is the 4 in column 9? It has to be here. This can't be 1 anymore. Where's the 1 in box 6? It has to be here. So this is 1. We have 8 ones. We know where the last one has to be. It has to be here. How about 2s? We have the 2s already. The 3s. We have 8 3s. We know where the last 3 has to be. It has to be here. 4s. We don't know where those are. 5s. We don't know where those are. 9s. We have 8 9s. We know where the last 9 has to be. It has to be here. What about 8s? 8s. This can't be 8 here. This is 5, 6, or 7 here. 5, 6, 7, 8, but 8 cannot be here. These can't be 7. This is 5, 6, or 8 here. These two digits are 5 and 6, which eliminates 5 and 6 in the rest of the row. So this can't be 5 or 6. That makes this 7. These can't be 7, and this can't be 7. This is a 5, 6 pair, which forces this to be a 4, 7 pair. We have a 5, 6, 5, 6 pair in column 2, which eliminates 5 and 6 in the rest of the column. So this can't be 5 or 6. This is 7, which makes this a 6, which makes that a 5, which makes that a 6, which makes that a 5. This can't be 5 or 6 here. This can't be 6 here. So this must be 5, which makes that 6, which makes that a 5. None of these can be 5, and this can't be 6. This can't be 5. And this can't be 6 either because of the 6 in the column. So this is 8, 7, 6. This can't be 5 or 6, so this is 7. This can't be 6 or 7, so this is 5. No 5, 7 here. This is a 4, 6 pair, which eliminates 4 and 6 in the rest of the box. This can't be 6. This is 5. This can't be 5 or 6, so this is 7. This has to be a 6, which forces this to be 5, this to be 6. 7. This can't be 5 or 8, so this is 6, which makes this 5, which makes that a 4, which makes that a 6. That's a 6. This 4 eliminates 4 here, so that's 7, 4. This can't be 5 or 6, so this must be 8. This 6 eliminates 6 here, so this is 5. This 8 eliminates 8 here, so this is 7, and this is an 8. And that's how you solve it. Yeah, pretty interesting. This mix of the skyscrapers with the German whisper lines definitely restricts things a lot, right? So, pretty cool, pretty cool. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.